All right, so example 10.1.3, computing predicted values and residuals. So part A says to use the regression equation to predict the number of calories when the alcohol content is 6.5% based on the data given table 10.1.2 from a random sample of 9 beers. So again, this is the alcohol and calorie content in the beer without the outlier. So again, remember we took out O-duals. Okay. All right, so the one that's highlighted in here will have meaning in one of the later parts that's asked here. But again, here's our data of our 9 beers that we're looking at, their alcohol content and calories. All right, so our random variables are still the same. So X, we're still looking at the alcohol content in a randomly selected 12-ounce beer. And our random variable Y is going to be the number of calories in that same randomly selected 12-ounce beer. So in this case, the particular value of X that they gave us was 6.50. Now, it was 6.50%, and we're not dividing this by 100 and writing it as 0.0650 because we've entered this list of data as 4.7, 6.7, 8.1, and so on in our list in L1. And so in this case, X is 6.50. The percent's kind of being treated here just as a label, like inches or feet. Okay. So it wouldn't be wrong. So we could have had you inputted all of the data, all of these as like 0.05, 0.05, 0.047. Then we would have entered this as 0.065. So it would have been correct to enter the data that way as well. It's just not what I did when we got this particular equation. So first we need to check that 6.5 is between the X min and X max. So in this case, we need to check and see if this is between 4.15 and 8.1. And it is. Okay, so that means it's a legal value to plug into this particular equation. So now we're going to take y hat, and in place of x, we're going to put 6.50. So we're going to take that 25.0312, 3606 plus 26.31860776 times x, which we're replacing that with 6.50. And if we compute, that gives us about 196.1 calories. Now, there's a lot of decimal places in each of those numbers, but remember, we stored this equation in Y1. So an easier way to have the calculator do all these computations and keep all the decimal places on these numbers for us is to compute y hat of 6.50. We can just tell it to use that equation we stored in Y1 and to plug in 6.50 for x. So again, to get those, oh, here they are right here. All right, so the key punches to type a Y1 are again variables, right arrow 1, 1, but then we would open a parentheses and type 6.50 and close that parentheses, and again we will get the answer of 196.1 when we round that value off. So again, if we've stored the equation, then again we don't need to write out all of this longhand and we don't need to type in all of those decimal places because they're already stored in that equation for us. So if we interpret that, that means if you are drinking a beer that has 6.50% alcohol content, then it is predicted, we don't know for sure, so it's predicted to have 196.1 calories. So notice the mean number of calories of the sample of 9 beers is about 170.2. Okay, so this 170.2 calories, that's X bar. Okay, so if we were, oh sorry, number of calories, that's the output, Y bar. Okay. So if we were to add up all of the calories for the 9 beers that we have and divide by 9, or if we were just to use the calculator to compute that for us, the average calories in these 9 beers is 170.2. Okay, now the value of 196.1 seems like a better estimate than the mean when looking at the original data, and that's because the regression equation, it takes into account the alcohol content. So instead of just looking at the average for the whole group, kind of like we did in these first units in this particular course, now we're going to be taking into account another variable that probably influences this value for these outputs for calories. All right, so part B says to use the regression equation to predict the number of calories when the alcohol content is 2.00%. All right, so now in this case, our specific value of x is 2.00. So again, we would first check that 2.00 is between our x min value of 4.15 and our x max value of 8.1. Okay, but it's not. Okay, so 2.00 is not between 4.15 and 8.1. Okay, which means the equation should not be used to predict the calories for this beer. We also should not use the mean from the sample of 12 beers either, since there were no beers in the sample with an alcohol content as low as 2%. All right, so this final part here deals with the concept that students, it takes a little bit of doing to kind of wrap their heads around what a residual is, but to find the residual associated with the beer that had 6.7% alcohol. So in this case, our specific value of x now is 6.70. So now a residual is defined to be the actual y value for a given x minus the predicted y value, again for a given x, which in this case is our 6.70. So we're going to take the actual value of y that we saw in the data minus this predicted value of y that the equation would give us if we were to plug in 6.70. So to get the actual value of y when x is 6.70, we need to look in the data table. Okay, so that is why we have that particular beer highlighted back there. So if we scroll back up here, okay, the beer, if we're looking in this list, there's only one beer that has an alcohol content of 6.70, and the calories for that beer is 215. All right, so this beer is highlighted in the table, and this beer has 215 calories. So using math notation, we have y of 6.70 is 215. Now, to get y hat of 6.70, we need to use the equation, because the hat is the predicted value. So we're going to use the equation to make their prediction. So again, we're going to take the same equation we had before, and we're going to plug in 6.70 for x. And if we do that, we get about 201.4 calories. Now again, here I've showed it here in the with all of the decimal places, but again, to get y hat of 6.70, you could have used y1 of 6.70 instead of typing all of these decimal places, and it would give us the same thing of 201.4 calories. So this beer with 6.7% alcohol actually had 215 calories, okay? But the linear model, so the linear model is this thing, okay? So this is a linear equation. So the linear model predicted that it would have 201.4 calories. Okay, so what actually happened and what we predicted to happen aren't exactly the same. Okay, and the residual measures the gap between those things. Okay, so the actual value of y was 215 calories minus the predicted value, which was roughly 201.4 calories. And so if we subtract those, we get a difference of 13.6 calories. Okay. So that residual means, and I'm just going to put a plus here just to emphasize that it's a positive difference. So this residual means that the actual value was about 13.6 calories above or more than the predicted value. Now, had we subtracted these and got a negative, let's say this came out negative 13.6, then that would say that the actual value was about 13.6 calories below the predicted value. So in the interpretation, we would still have a positive number, but the word above would be changed to below.